Hello friends, in this video I am going to teach about what is comparator and types of comparator. Let's see first what are the outcomes of this video. The first outcome is comparator. In this comparator we will go to discuss about the definition of comparator and types of comparator. Means there are two types of comparator. The first one is non-inverting comparator and second one is inverting comparator. We will go to discuss about these three topics in this video. First let's see what is comparator. First, see comparator definition. A circuit which compares a signal voltage applied at one input of op-amp with a known reference voltage at the other input and gives the output whether the input is greater or less than the reference voltage. Here the comparator is nothing but it compares the input of the op-amp. Here we are going to give the one input of the comparator is unknown voltage or unknown signal, and the other input is known signal or known voltage, that is also known as reference voltage. Now that unknown voltage is compared to the known reference voltage. According to that the output is varied. Okay, this is known as comparator. And the open loop op-amp act as a comparator. Here we are using open loop op-amp as a comparator, and we have only two possible outcomes for the comparator, that is plus Vsat and minus Vsat, that is plus or minus Vsat. Vsat is nothing but saturation voltage. These are the two possible outcomes of the comparator, and we have mainly two types of comparators. One is non-inverting comparator and another one is inverting comparator. First let's see what is non-inverting comparator. Here first study the definition of non-inverting comparator. The fixed reference voltage is applied to the inverting terminal and time varying signal, that is Vi, is applied to the non-inverting terminal. Here as the name indicates, non-inverting op-amp is nothing but here we are going to apply the input or unknown voltage Vi is applied to the non-inverting terminal and the known reference voltage is applied to the inverting terminal. Then the type of op-amp is known as non-inverting op-amp. Here let's see, this is the non-inverting op-amp configuration. Okay, this is the non-inverting op-amp configuration. Here let's see, this is the non-inverting op-amp, that's why I applied VIN voltage, that is unknown voltage, to the non-inverting terminal, that is positive terminal, and I applied the reference voltage, that is known voltage, to the inverting terminal, that is known voltage I applied as 1 volts. Okay, here observe D1 and D2, two diodes are connected between the inverting and non-inverting terminals. These diodes are also known as protection diodes. These are used to protect our op-amp from high voltages. Okay, these are using for protecting diodes, and this R1 and R are the input resistances. Okay, this R1 and R are the input resistances. Now let's see here, if our input VIN is greater than this reference voltage, here observe, this VIN is our input voltage and VREF, that is equal to the 1, is our reference voltage. If our input is greater than our reference voltage, then the output is plus saturation. Okay, if the input is less than our reference voltage, then the output is minus saturation. Likewise the output varies. Okay, if the input is greater than our reference voltage, then the output is plus saturation. If the input is less than the reference voltage, then the output is minus saturation. Here observe this tabular column, here VIN, if VIN is less than V reference, I already told you, if VIN is less than V reference, then the output, what is output? Minus Vsat, that is negative saturation. Okay, now let's see here, the voltage at the terminal V2 is greater than the voltage at the terminal V1, that is if the reference voltage is greater than the input voltage, then the output is nothing but, what is the output? Then the output is minus saturation. Suppose if the input VIN is greater than the V reference, that is our reference voltage, then the output is plus Vsat. Then we can write this as a, the voltage at the positive terminal, that is V1, is greater than the voltage at the negative terminal. Okay, if the voltage at the positive terminal is greater than the voltage at the negative terminal, then our output is plus saturation. Here observe V naught equal to A into VID. VID is nothing but input differential voltage, that is V1 minus V2. Okay. Now let's see what are the waveforms for the non-inverting op-amp. Here observe, these are the waveforms for the non-inverting comparator. If suppose I took the V reference as a positive, that is let take the V reference as a plus 1 volt, then the waveform will be like this. If the V reference is minus 1 volt, then the waveform will be like this. Now I am going to explain the waveform how it is varies according to the input. If suppose this sinusoidal wave is our input, consider here the sinusoidal wave is our input, then if the sinusoidal wave is our input, then consider the positive V reference, that is here this dotted line. This dotted line indicates the positive V reference. If our input is greater than the positive V reference, then our output is plus Vsat. If the input is less than the V reference, then the output is minus Vsat. Here observe, this is the input sinusoidal wave. Whenever this input sinusoidal wave is more than the reference voltage, then here observe, this is the output. This is the output voltage and this is the input voltage. Whenever the input voltage is greater than the reference voltage, then the output is plus saturation. Here observe, plus saturation. Whenever the input is less than the V saturation, then it will go to negative saturation. And again, whenever the input is more than the V reference, then again it will come to the positive saturation. Okay, this is about positive reference voltage. If suppose I take the reference voltage as negative reference voltage, then the waveforms will be like this. Suppose here consider minus 1 as our reference voltage, that's why I take the reference voltage in negative axis, that is minus V reference. Whenever the input is greater than this minus V reference, then the output is plus Vsat. Here observe, then the output is plus Vsat. Whenever the input is less than the minus V reference, then the output is minus Vsat, and again the same thing is repeating. These are the waveforms for the non-inverting op-amp. Now let's see inverting op-amp. Let's see here inverting comparator. Here the reference voltage V reference is applied to the positive terminal of the input, and the input is applied to the input, nothing but VIN is applied to the negative input terminal. In previous case, we applied the input to the non-inverting terminal, that is positive terminal, and the V reference is applied to the negative terminal. Here exact reverse operation of the non-inverting comparator, that is here we are applying the input to the inverting terminal and reference to the non-inverting terminal. Let's see here the circuit diagram. In the circuit diagram, let's consider here negative terminal or the inverting terminal of the op-amp is connected to the input VIN, and non-inverting terminal is connected to the reference voltage, and these two diodes are used for protecting our op-amp from high voltages. This is exactly same as the non-inverting comparator, except here we are just interchanging the input terminals. Okay, here let's see, if the input voltage, that is VIN, is greater than the V reference, then the output is minus Vsat, and VIN is less than the V reference, then the output is plus Vsat. Now let's see the waveforms. These waveforms are exactly opposite to the non-inverting comparator. If I take the V reference as positive, that is positive plus 1, then the waveforms will be like this. If I take this dotted lines indicates the reference voltage. If our input is more than this reference voltage, then the output is minus saturation. Okay, if the input is less than the reference voltage, then the output is plus saturation. If the input is again greater than the reference voltage, then the output will become as minus saturation. Likewise, the output of the comparator varies according to the input. Okay, now let's consider if suppose V reference equal to minus 1 volt, V reference equal to minus 1 volt. Now let's consider the V reference as minus 1 volt, that is here dotted line indicates the V reference. If whenever the input is greater than the V reference, then the output is minus saturation. Whenever the input is less than the V reference, then the output is plus saturation. Likewise, the waveforms varies according to the input and the reference voltages. Now let's see what are the applications of comparator. Here these comparators are used in window detector, time maker generator, phase meter, zero crossing detector. And this is the circuit diagram for zero crossing detector, and these are the waveforms for zero crossing detector. In my next video I will go to in detail about zero crossing detector. I hope you understood this topic. Thank you for watching this video.